Alright, this is part 2. I had some technical difficulties before. Alright, so let's continue with 42. So let's start off by making a graph. Okay. Oh, it's a little messy. Okay. So from here, let's label all these values right here. So what is our A? Our A is -1. Our X is going to represent X. 4 is going to be our H. And remember, it says +4 there, but if you remember our original formula, let me write it down over here again. Y is equal to AX minus H squared plus K. Oh. Right here, notice that it's to the power of 2 plus K. So that means this over here is going to be our K. Alright, so how do we figure out what our vertex is? Well, the vertex is represented by H, comma, K. That means our vertex is going to be -4, comma, 2. Alright, let's go ahead and graph this now. So, how do we graph -4, comma, 2? Since it's -4, that means we're going to have to go 4 to the left, 1, 2, 3, 4, and up 2, 1, 2. So that'll be right there. And now, what else do we need to do? We need to try plugging in a few more points. Let's try the number, let's see here. We can try plugging in, let's try 2. If we plug in 2, we have 2 plus 4, which is 6, to the power of 2, which is 36, which gives us -36, plus 2 is going to be -34, and that's going to be way down here. Okay, so actually let's go ahead and fix the scale right here since we're not going to have enough space. Okay, so we're going to go in increments of 4. Let's make this smaller. And go by increments of 4. Since there's not enough space, I'm going to do this. 16, 24. Okay, we're going to continue with this with just 1s, 2, and 4. See, these are all negative. Okay, so 1, 2, 3, 4. Okay, and then we have to go up 2, 1, 2. But our scale here would mean that we only go up to this point right here. So that'll be our vertex. And our second point, let's make a table right here. So our x is -4 and 2. And looking at the equation that we have, will it be facing upwards or downwards? Well, a is -1, which means it will be facing down. Okay, so let's try plugging in 1 into our original equation. So 1 plus 4 is 5. 5 squared. Actually, that'd be a little tricky to graph. So let's go with -3. So -3 plus 4 is +1. +1 squared is 1. But we're multiplying by negative, so we'd have -1 plus 2, which gives us -1 plus 2 is 1. So if we plugged in -3, we get 1. So let's do this. 1, 2, 3, and then we're going to go up 1, which would be right around here. And since this is our axis of symmetry right here, it's going to be reflected 1 to the left as well. So it'll be right around there. It's kind of hard to draw in here. Okay. And now, let's try a couple more points. Let's try -1. Because we want to try making this graph a little bit bigger. Okay, so -1. You write that down over here. So -1 plus 4 is 3. 3 squared is 9. 9 times -1 is -9, plus 2 gives us -7. So -7, -1, -7 would be right over here. So 1 to the left and down 7. So let's do this in a different color actually. So that would be right around here. And remember, since our axis of symmetry is right over here, this will have reflect on the other side as well. So at this point right here is 1, 2, 3 to the right. So we're going to do 3 to the left. 1, 2, 3. Same y value, but just the opposite. It needs to reflect. Okay. So now let's connect these points right here. The graph is going to look something like this. Okay. So it will be facing downwards. And so when we describe this in comparison to x squared, we're going to say that the graph of n is a reflection in the x-axis and a translation of 4 units to the left and 2 units up of the graph of x squared. Okay. So now, let's work on number 60 in the book. They're smaller. Okay. So number 60 asks us to write a quadratic function in vertex form whose graph has a given vertex and passes through the given point. Okay, we can remove this now. Okay. So our vertex is 1, 8, and the point has to pass through 3, 12. So once again, the first step would be to figure out what our formula is that we'll be using. We're going to need this one. We're going to need to know what the vertex form is, because we're provided the vertex. Okay, so now our vertex is 1, 8. 1 is going to be our h. So we're going to go ahead and recreate our equation over here. We're going to leave x alone for now, and our h is 1. Notice how it's now negative. It looks like it's -1 here, but it's actually +1 because of this negative symbol right here. And plus 8 right here. Remember, don't mix up the vertex and the point that you're provided with. Make sure that when you plug it back to the equation, you're plugging in the vertex into the correct variables. And now, how are we going to figure out what a is equal to? Well, we don't have a, so we're going to have to use this point right here. It says that it passes through 3, 12. Well, we need to remember that 3, 12 is a coordinate that can be represented with x, y. So that means we can go ahead and replace this x with this x right here, and we can replace this y with the y right here. So we'll replace the y with 12 is equal to a, and the x is 3. So we're going to replace x with 3. and rewrite the whole equation. And now the only variable that we have to solve for is a. If we're able to solve this whole equation, we'll be able to figure out what a is equal to. Okay, so now 3 minus 1 is 2. 2 squared. So let's go ahead and rewrite this. Plus 8. And now I have 12 is equal to a. 2 squared is 4. So we're going to rewrite this as 4a plus 8. And we can subtract 8 on both sides. Let me see, move this over here. Let's see. Let's do this over here actually. So 12 minus 8 is equal to 4, which is equal to 4a. And if we divide 4 by 4, we're left with a is equal to 1. Because if we divide 4 by 4, we get 1. So that means when we rewrite our equation over here, we're going to replace a with 1. This equation right over here. Actually, no, it's this one right here. Let's circle that one real quick. We're going to replace a right here. So let's rewrite this over here. Our new equation is going to be y is equal to 1 x minus 1 to the power of 2 plus 8. And we don't need to write this 1 because 1 times anything doesn't change the equation. So it's x plus 1 squared plus 8. And that will be your equation. Okay, let's try the next one. Similar to the problem we already have. Alright, so this one's number 62. So we need to write a quadratic function in vertex form whose graph has the given vertex and passes through the given point. Once again, let's write our equation that we're going to need to use, our formula I mean. x minus h squared plus k. Okay, so we're going to keep y and a the same, but we're going to have to change everything else. So what are we going to replace h with? Well, our h over here is negative 5. So let's plug that in. So we're going to plug in negative 5 right here, and our k is negative 1. So we're going to write negative 1. And the toughest part of this is making sure that you put the correct points into the equation. Make sure you don't accidentally put in these points for h and k. Okay, so now we have y is equal to x minus times negative 5. So that would be equal to x plus 5. A negative times a negative is positive. Okay, so from here, what can we do next? We need to figure out what a is equal to. Once we figure out what a is equal to, we'll have our quadratic function in vertex form. So, if you might have guessed this already, we're going to need to use this point right here. It has to pass through negative 2, 2. So let's go ahead and plug this in. Negative 2, 2. So, which one's x and which one's y? The left one's x and the right one is y. So let's plug in 2 for y, leave the a alone, and we're going to plug in negative 2 for x, plus 5 to the power of 2 minus 1. And then we have 2 is equal to negative 2 plus 5 is 3 squared minus 1. 3 to the power of 2 is 9. So we're going to write 9a minus 1. And to get rid of this negative 1, we're going to add 1 on both sides. Oh. Okay. Add 1 on both sides. 2 plus 1 is 3 is equal to 9a. And to get a by itself, we're going to divide both sides by 9. And that gives us 3 over 9, which is the same thing as 1 over 3. So our a is going to be equal to 1 over 3. And let's see if we can figure out how to put it back into our original function. So our original function is right over here. Let's get this over here. So we need to rewrite this. And when we rewrite this, it's going to look like this. Our a is 1 over 3, so we're going to replace it with 3. Oh, what's going on here? One over 3. And then x plus 5 over 2 minus 1. Okay, and that is your answer. Oh, seems to be disappearing. Okay,